Let's install Consul on Kubernetes with Minikube. This is a relatively quick and easy way to try out Consul on your local machine without the need for any cloud credentials. You'll be able to use most Consul features right away. First, you'll need to follow the directions for installing Minikube, including VirtualBox or similar, Kube Control, and Minikube itself. You'll also need to install Helm, which is available at helm.sh. Next, start Minikube. I like to use the memory option with 4 to 8 gigabytes, so there's plenty of memory for all the pods we will run. This may take a while. On my machine, it had to download a few hundred megabytes of dependencies and container images. Next, let's start the local Kubernetes dashboard with Minikube Dashboard. Even if the previous step completed successfully, you may have to wait a minute or two for Minikube to be available. If you see this error message, try again. Once it spins up, you'll see the dashboard in your web browser. You can view pods, nodes, and other resources. To perform the steps in this lab exercise, clone the HashiCorp Demo Consul 101 repository from GitHub. Change into the repo and go to the Kubernetes directory inside. Now we're ready to install Consul to the cluster using the Helm tool. Initialize Helm with Helm init. You'll see a note that Tiller, the server-side component, has been installed. You can ignore the policy warning. Now we need to install Consul with Helm. To get the freshest copy of the Helm chart, clone the HashiCorp Consul Helm repository. The chart works on its own, but will override a few values to help things go more smoothly with Minikube and to enable useful features. We've created Helm Consul values.yaml for you with some overrides. See values.yaml in the Helm chart repository for other possible values. We've given a name to the data center running this Consul cluster. We've enabled the Consul web UI. In this case, it specifies that a load balancer is needed. This will only work when deployed to a hosted cloud that implements load balancers, which Minikube does not. You could use a node port here, or leave it as is and we'll access the Consul UI in another way. We'll enable secure communication between pods with Connect. We also need to enable gRPC on the client for this to work properly. Finally, specify that this Consul cluster should only have one server, which is suitable for local development. We also set a pod disruption budget to give Kubernetes a hint that we always want our Consul server to be running and it should never be arbitrarily shut down. Now run Helm install together with our overrides file and the cloned Consul Helm chart. You can verify this by going to your web browser and finding the list of services. Several include Consul in the name and have the app Consul label. Let's use a feature of Minikube to find the URL to our Consul web UI. Run Minikube service list to see all the services that Minikube knows about. Find the one that has Consul UI in the name, and run Minikube service with that Consul UI value. When you hit enter, it will open your browser to the IP address and port of the Consul web UI. We see services, nodes, and other resources known by Consul. Now let's deploy our application. It's two services, a backend data service that returns a number, the counting service, and a front-end dashboard that pulls from the counting service over HTTP and displays the number. The Kubernetes part is a single line. kube control create -f 04 YAML connect envoy. This is a directory with several YAML files, each defining one or more resources, pods, containers, load balancers, etc. The output shows that they have been created. In reality, they may take a few seconds to spin up. Refresh the Kubernetes dashboard a few times and you'll see that the counting and dashboard services are eventually running. You can also click a resource to view more data about it. Use the port forward feature to expose a port from a pod in the cluster to a port on your local machine. We already know that the pod is named dashboard thanks to the metadata specified in the YAML we deployed. Visit localhost 9002 in the browser. You'll see a running dashboard container in the Kubernetes cluster that displays a number retrieved from the backend counting service using Consul Service Discovery and secured over the network by TLS via an Envoy proxy. Let's take a peek at the code. Relevant to this Kubernetes deployment are two YAML files in the 04 directory. The counting service defines an annotation on lines 5 and 6 that instruct Consul to spin up a Consul Connect proxy for this service. Connect inject. The relevant port number is found in the container port section on line 12. This pod registers a Consul service that will be available via a secure proxy. The other side is on the dashboard service. This also declares the same connect inject annotation, but also adds another. The connect service upstreams on line 9 configures connect such that this pod will have access to the counting service on localhost port 9001. All the rest of the configuration and communication is taken care of by Consul and the Consul Helm chart. Now within our dashboard application, we can access the counting service via localhost port 9001 as seen on line 19. Here we're looking at an environment variable that is specific to the Go application running in a container in this pod. Instead of providing an IP address or even a console service URL, we'll tell the application to talk to localhost port 9001, where the local end of the proxy is ready and listening. And because of the annotation on line 9, we know that an instance of the counting service is on the other end. So this is what is happening in the cluster and over the network when we view the dashboard service in the browser. For a final task, let's take this a step further by restricting service communication with intentions. We don't want any service to be able to communicate with absolutely any other service, but only the ones that we specify. Begin by navigating to the intentions screen in the console web UI. Click the Create button and define an initial intention that blocks all communication between any services by default. Choose star as the source and star as the destination. Choose the Deny Radio button and add an optional description. Click Save. Verify this by returning to the application dashboard where you will see that the counting service is unreachable. Finally, the easy part. Click the Create button again and create an intention that allows the dashboard source service to talk to the counting destination service. Ensure that the Allow Radio button is selected. Optionally, add a description. Click Save. This action does not require a reboot. It takes effect so quickly that by the time you visit the application dashboard, you'll see that it's successfully communicating with the backend counting service again. And there we have Consul running on a Kubernetes cluster as demonstrated by two services which communicate with each other via Consul Connect and an Envoy proxy. We encourage you to clone this repository and try it out yourself with Minikube.